Hello everybody. In today's video lesson, what we're going to be talking about is how you change an exponent into a logarithm and a logarithm into an exponent. Now, leading up to the unit that we're currently working on, we have been discussing the concept that logarithms and exponents are inverses of each other. And we practiced how you find the inverse of any particular function. There was a process for it. Well, there is also a process that will allow us to convert a logarithm to an exponent and vice versa. And that's what this lesson is going to be focusing on today. So here's the first kind of thing that we're really talking about in our curriculum dealing with logarithms. And it's how you change forms from one to another, exponent to logs, logs to exponents. So what you're seeing on the screen right now is a function, very typical of what you might see. We have function f that is equal to log of a base called a, and the input number is still x. So the way that we would read it is f of x is equal to log base a of x. Okay, and I am not super thrilled that they're giving me the variable a as a base. Generally speaking, we would use a lowercase b to represent a base because the variable a might represent, usually in transformations, vertical, stretching, compressing, and reflections, but I digress. So that is how we would read that function. We would say f of x is equal to log base a of x. And what we're going to be practicing now is how you convert them from one to the other. So what you're seeing down here at the bottom, where it says y is equal to log base a of x, and on the right where it says a to the y power is equal to x, those are actually inverses of each other. And let's go ahead and show you how you create them. So there is a brief process that we are going to go through. Students generally pick this up quite easily, and it's, as far as a skill is concerned in mathematics, when it comes to exponents and logarithms, this is something that students generally do quite well with because it is a relatively simple concept to grasp, but you got to see how it works. Okay, so generally speaking, real quick, we have two types of logs that we're going to be working with. We have something that has log with a base 10 of some number, and we would refer to this as the common log. And because we would refer to that as a common log, we actually don't write the 10 a lot of the times. We just say log of x. So anytime you see a logarithm that doesn't look like it has a base, it's implied that it is a base of 10 because that's what the common log is. And if you look at the calculator that you happen to be using, there are two logarithm buttons, and one of them just says log. So all of our calculators are programmed to do logarithms in the common log by themselves. The other type of log that we're going to see that's very commonly occurring is log with a base e. Now remember, e is a transcendental number, 2.718, but we don't write 2.718 because it's neater to just say e. This is called the natural log, and it is written as ln of x. So if you don't like seeing ln of x, you could always rewrite it as log base e of x, because when we start doing more work with logarithms, you will see ln of x a lot more than you'll see log base e, but they're the same thing. So these are the two types of logs that we're going to be looking at. And so now moving on to how you could do the converting. Now again, keep in mind here, I'm going to take a look at the one on the left first, where it says log base b of x is equal to a. So here's the base. What we're going to do is we're going to kind of create a loop. I'm going to say here. Then we got log base b. The way that we convert it is we're going to say uh, b to the a power, whatever a happens to be, equals x. Okay, so when I say b to the a power, I'm going to just write b as the base raised to whatever power a happens to be, and it is equal to x. And that's how you convert a logarithm into an exponent. And yes, it really is just that simple. Okay, so now let's take a look at the one on the right. Now here, remember, this is our base. The b is representing the base of our exponent. So here, the way I would read this, when I try to convert it, this is how I'm going to think about it. I'm going to say log base b of x equals a. So the way I'd write it, just the way I read it, log base b of x is equal to a. And you see how we're going to be converting those from one form to the other. Okay, so at this point, guys, again, as you're going through it, if you have any questions, make sure you're writing them down so that way when you come see me in class, you have questions ready to go. So let's go ahead and take a look at these three functions here. We have three, well, these aren't really functions. These would be more like logarithm equations. But what we're trying to do here is convert a log equation into an exponent. And we're going to use that loop method that I just showed you. So I'm not going to write in detail all three of these, but I'll do it for the first one, and then I'll just kind of explain it as I go through the other two. So here, the 4 is the base. So I would say 4 to the third power equals 64. So the way that we convert it is we're going to say 4 to the third power is equal to 64. And that would be all we do as far as, our answer is concerned. Okay, so moving on. Now here they're trying to trick us up a little bit because they put the log on the right side of the equal sign as opposed to the left side. But that's okay. It doesn't change anything. Here's the base. So I'm going to say that base raised to whatever this number is. So I say 81 to the 1/2 power, and it has to be equal to this other number here, 9. And the last one, 10, is the base. So I'm going to say 10 raised to the negative third power must equal whatever this other number is, in this case 0.001. And that's pretty much it as far as how you convert a log into an exponent. Okay, and this is going to be a useful skill when it comes to solving logarithm equations because sometimes when we're trying to solve a log equation, this is just going to be something that's very useful for us because the bases may not always be the same in a log equation, and so we need to know how to convert them so that way we can see how we could get a common log with exponential equations, or a common base, I should say. So here are the last three examples that we're going to look at, and it's essentially just the opposite of what we were just doing. We're going to take these exponential equations and rewrite them as a logarithm. So remember here, this is a base, and what I'm going to do is I will go ahead and, on the first one, kind of write out the explanation, and on the other two, I'll just walk you through it verbally. But here, we would say log base 2, okay, that's what the 2 is, of 1 over 16 equals the negative 4. So the way I write that is I'm going to say log base 2 of 1 over 16 equals negative 4. And that would be again, the extent of that particular skill, because all we're doing is converting it from one form to another, and we're done. So we'll follow along on the other two examples here, just a little bit verbally. But here on the left side, uh, this one doesn't really require much in the way of explanation about why they're equal, because anything to the first power is itself. But uh, because the exponent is expressly written on the left-hand side, that is the one that we'll look at as far as where my base comes from. So I'm going to say log base e of e has to equal 1. So I'd say log base e of e has to equal 1. Or, because log base e is known as the common log, I can say the natural log of e is equal to 1. And you could type either one of those on your calculator. Well, actually, the one on the right is the one that you'd have to type on your calculator, because log base e is not something that your calculator understands unless you push the button that says ln, because that's what the calculator knows is log base e. So if you want to type this into your calculator, that is where you could very easily see, yeah, it's equal to 1. Okay, and the last one here, this is the base of the exponent. So I'm going to say 10 log base 10 of 1 over 100,000. So log base 10 of 1 over 100,000 is equal to -5. Or, because log base 10 is the common log, we often don't write the 10 as the base. We would just also be able to say log of 1 over 100,000 is equal to 0 or -5. I'm thinking of the last page example, is equal to -5, because it's understood that if you write just log with no base, it's implied that the base is 10, because that's the common log. And there you go, guys. That's pretty much it as far as how you convert a logarithm into an exponent, or an exponent into a logarithm. And it is going to be a skill that we will employ when it comes to solving logarithmic equations, because oftentimes we have equations that don't have the same bases, and we have to figure out, well, how could I get a common base? And the easiest way to do that is to convert it into exponents. And so again, if you have any questions, make sure you have them written down and bring them to me when you see me next in class. And thanks for watching, and see you soon. Bye.